Additive manufacturing has seen a growth in adoption in the aerospace, automotive, and defense industries. However, the marine and offshore industry has seen a slower adoption rate. In this episode of AM Infocast, we connect with Dr. Tan Jie Lun, Project Manager, Additive Manufacturing, Shippartscom, to discuss the challenges holding back the adoption of additive manufacturing in the marine and offshore industry. Tune in to understand how the marine and offshore industry can take advantage of additive manufacturing, cost dynamics of additive manufacturing against conventional manufacturing in the context of maritime applications, and how the future looks for additive manufacturing in the marine and offshore industry.
Hello, Jie Lun. Welcome to AM Infocast. Great to have you here on this conversation.
Hi Aditya, it's a pleasure to be here.
So, Jie Lun, Shipparts.com is an online procurement platform for the marine and offshore industry. How does additive manufacturing fit into the scheme of things at your organization?
Okay, so let me share more about Shipparts. So Shipparts.com was founded in 2015 as an e-procurement platform for marine spare parts. So our core business model remains as a trading platform between buyers and sellers. So sellers will list their products on our platform and buyers will search for these products and then make the necessary purchase. We'll then provide the logistics to deliver the parts from sellers to the buyers. So as we progress over the years, we have decided to expand into Industry 4.0 to improve the business model. So right now we have a strong team working on artificial intelligence to optimize inventories for marine spare parts. Every vessels will carry spare parts for replacement so that their operations will not be hindered in case of equipment failure. However, the ships cannot be carrying spares for every piece of equipment, as this will take up space that could be used for charter. So this is where AI comes in to strategize the inventory allocation. Secondly, we are also working on predictive maintenance, where sensors are embedded in equipment and can predict when it will fail. The predictive maintenance system will then trigger an advanced inquiry for spare parts to be ordered and delivered to the next port of call. Lastly, we are incorporating additive manufacturing because it has the capability to manufacture the parts in different locations around the world without the needs for die or molds. So you can simply print a part, post-process it, and use for operations. So in summary, we are using AI to reduce inventory, predictive maintenance to identify which part will be failing, and lastly, we'll be using AM to print the part at the nearest port of call. So overall, we are looking into utilizing this technology to digitalize the maritime spare parts market.
That's great. And what's happened traditionally is transportation, aerospace, and defense industries have seen rapid adoption of additive manufacturing in the last few years. However, marine and offshore industry has been a little slow off the block. What challenges do you feel are holding back the adoption of AM in this industry?
Let me explain more about the other industries. So for the aerospace, automotive industries, they have major players such as Boeing, Airbus, GE, BMW. So these companies, they have the capital and resources to set up their own AM centers. So BMW, they have AM facility in Germany, where they do research and prototyping with AM. GE also has an additive manufacturing branch known as the GE Additive, which they can work with. So for the defense industry, we know that countries are willing to spend to stay ahead of the curve. So if AM can provide an advantage, governments will be willing to invest in the technology. We have seen a surge in interest by the military in AM. And recently, earlier this year, the US Department of Defense has released its additive manufacturing strategy, showing its commitment to using AM. However, for the marine and offshore industry, it is fragmented with many small and medium suppliers having limited resources to venture into AM. So these companies may not be keen on exploring with AM since they're unsure of its capability and potential. Next, intellectual property is also an issue when it comes to manufacturers. They have put in resources and research in development to come up with their designs, and this is why they are hesitant in handing over their designs to service bureaus to be printed. They are worried that their designs will be shared freely, and anyone can access their designs and print the parts without their permission. So this will result in loss in revenue, and they will not be able to recover the cost that they have invested in coming up with the designs. So this is where Shipparts.com role in providing reassurance to our supplier base is crucial. So not only do we have to convince them that the printed part quality will meet their requirements, but also ensure that their designs are protected and not exploited by third parties. So besides the manufacturers, we have also the assurance bodies or the class societies. So in aerospace, we have two major bodies. They are the Federal Aviation Administration and the European Union Aviation Safety Agency. However, for marine and offshore, we have 12 major class societies. They are responsible for over 90% of the standards for the world cargo carrying ships. And each class society, they will have their own sets of AM guidance, which can result in different sets of procedures or requirements to certify the AM readiness of a part. So these are some of the key challenges faced by the marine and offshore industry.
Yeah, that's good deep insight into how marine and offshore industry looks at AM. And additive manufacturing enables industries to explore distributed manufacturing and build digital inventories. How do you think that marine and offshore industry can take advantage of that?
Okay, so ships are mobile assets and they are always on the move. So when a critical part fails and they need an emergency replacement, the ship owners will place an order. But if there's no stock for the parts, the ship owners will have to wait for these parts to be manufactured in the manufacturing facility, which could be in another country, and have it shipped or air freight over to the country where the ship is. So the part will have to go through custom clearance, where in some countries it could take 2 to 3 weeks just to clear and another few days just to get the part delivered to the ship. So overall, this process could take more than a month. This will result in loss of charter since the ship is unable to operate. So while AM parts can be costly compared to traditional manufactured parts, the monetary loss due to the ship waiting for the part replacement can be substantially more than it takes to print the part. Distributed manufacturing also reduces the lead time. So parts manufactured within the country where the ship is do not have to go through custom clearance. They can also save on the transportation time since it reduces the distance between the point of manufacturing to the delivery location. Having a ready digital inventory can also allow ship owners to order and print off the shelf instead of having to go through the steps of getting the 3D model, print, and having the parts qualified for AM. Next, ships have a typical lifespan of 25 to 30 years. So during these years, some manufacturers may cease the production of certain parts. And this is where AM is useful in producing these legacy parts that are unavailable in the market. Having digital inventory also means manufacturers do not have to rely on die or mold to cast a part. They only need to keep a copy of the 3D files and they can produce the parts using AM anytime and anywhere. So this helps frees up their inventory space and cost. So these are some of the examples of how marine and offshore can take advantage of digital inventories and distributed manufacturing capability offered using AM.
So, Jalen, what's your opinion about the cost dynamics of additive manufacturing versus conventional manufacturing in the context of the maritime industry? You've shared a few cases, but can you share any success cases of AM adoption in the marine and offshore industry?
So for us, we have always heard how costly AM parts are compared to conventional manufacturing. So we have this triangle of cost, quality, and time, where you can only choose 2 out of the 3. So let's say you choose a low cost and a short lead time, you end up with a poor quality part. So if you choose high quality and low cost, you have a long lead time. And if you choose a high quality and short lead time, you have to bear the high cost, which is where AM is. So right now, there is no guidance or tools to facilitate the decision-making process. And most people will see the quote for AM parts and find it too costly and do not want to proceed. So for us, we have introduced 2 matrices to guide users to determine if they should consider AM for production. The first matrix is a cost versus improvement in the delivery time chart. So what it does is to compare the cost and lead time between traditional manufacturing and AM and allows buyer to make a decision. So for example, if a part produced using AM costs twice as much, but can shorten the lead time by 4 times, it will flag the part as being suitable for AM. However, if the lead time is same as the traditional manufacturing, it will then warn the buyer that this part is unsuitable for AM. We have also another matrix comparing the cost and the number of parts. So similar to traditional manufacturing, the more you produce, the lower cost per part since the machine operation costs are shared among more parts. In traditional manufacturing, nesting refers to the arranging of the parts to minimize the raw material wastages from methods such as CNC machining. So for AM, nesting refers to utilizing the build volume of the printer. So the more parts you can pack into a single print, the lower the machine operation cost per part. So what we have done is we have done a study with an impeller which costs approximately 1,000 Singapore dollars using traditional manufacturing method. So the cost of printing a single impeller is approximately 4,000 Singapore dollars. So next, we tried using nesting to print 6 of these impellers in a single print job. And the cost of each impeller drops to 2,000 Singapore dollars. So we can see that the price of printing a single impeller drops from 4 times of the original cost to 2 times. So of course, we don't have to print 6 impellers in a go. We can actually fill up the build volume with different parts. So once the marine and offshore industry, they have a better understanding of the cost dynamics of AM, they can slowly start to accept AM as part of their manufacturing strategy. And then this is where we'll see an increase in the adoption of AM in the industry.
And how does the future look like for additive manufacturing in the marine and offshore industry?
Okay, so the future of AM in the marine and offshore industry looks promising. Although it has a slower adoption rate, we can see it from another point of view that it actually has a lot of untapped potentials. So in the marine and offshore industry, there are thousands of spare parts. And once manufacturers understand that AM frees them from some of the design constraints that traditional manufacturing has, they can start to improvise their designs to make their parts more efficient. Having distributed manufacturing definitely helps in the marine and offshore, since ships are mobile assets and are not fixed at one location. So AM allows ship owners to have the spare parts printed in the next port of call and ready for collection. Having a shorter lead time by using AM also helps in their planning. They cannot predict accurately how long it takes for a part to clear the customs. So let's say the custom clearance takes 1 week, more than the expected, and the vessel has to leave before that. So the ship owners will have to rearrange for these parts to be delivered to the next destination. So this will result in additional logistical costs incurred. Also, in recent times, people are starting to talk more about sustainability. So in AM, in general, it generates less raw material wastages than traditional manufacturing methods such as milling, since AM only use what is needed. So for example, in the laser powder bed fusion, we can reuse the unused powders for the next print. But for milling, it will generate waste that will have to be collected and recycled. Also, we are looking at using AM distributed manufacturing to reduce the carbon footprint of parts. So with parts manufactured at a location closer to the buyers, the greenhouse gas emission from transportation will be reduced. Next, print-on-demand model with AM also helps to reduce greenhouse gas emission from the warehousing. So overall, we have a positive outlook for AM in the marine and offshore industry.
That's great, Jie Lun, and thanks for joining us today on this podcast and sharing your insights into how additive manufacturing can evolve and grow in the marine and offshore industry.
Thank you, Aditya. It's my pleasure to be here with you.
Thank you for tuning in for yet another episode of AM Infocast powered by AM Chronicle. See you in the next episode.